All right, in this video, we're going to continue with finding the actual zeros, some rational, some irrational, maybe even some imaginary for a polynomial. So in this case, for this example, we have f of x is x to the fourth plus x squared minus 12, and we're going to find all of the zeros. So by the rational zeros theorem, the potential rational zeros are the factors of 12 over the factors of 1, which it's always nice when you have a leading coefficient of 1 because then your rational zeros are a lot easier to find. But we have plus or minus 1, 2, 3, 4, 6, and 12. Now, if we check all of these, we'll find that none of them are actual zeros. So what do? How do we find the zeros of something when they're not rational? Well, if they're not rational, then there's one of two possibilities remaining. Either they are irrational, such as that square root of 6 over 2, that's an irrational zero, or they're imaginary. So it's possible to have imaginary zeros as well. If looking at x squared plus x minus 12, it actually is quadratic in form. So to be quadratic in form, we need three terms. So first term, second term, three terms, okay. And then the exponent on the first term, the 4 in this case, has to be twice that of the exponent on the second term. So 4 is twice of 2. So this quadratic is in exponential form. If this said x to the 6th plus x cubed minus 12, it would also be quadratic in form because we'd still have three terms, and then the 6 is twice that of 3. So if it's quadratic in form, we have a couple ways we can deal with that. So let's look at x squared for x to the fourth plus x squared minus 12 equals 0. We can actually factor this out. So if this was like y squared plus y minus 12 equals 0, we could solve that via factoring. We could also solve it with quadratic formula, but it'll be a little bit easier with factoring. So x to the fourth plus x squared minus 12 equals 0 is going to factor as x squared plus 4 times x squared minus 3. And we can multiply this out and check it. X squared times x squared is x to the fourth. X squared times negative 3 is negative 3x squared. 4 times x squared is 4x squared. So 4x squared minus 3x squared is 1x squared. So that works. And then 4 times negative 3 is negative 12. So x squared plus 4 times x squared minus 3 equals 0. So we have two factors multiplied together here to equal 0. We're going to set each one equal to 0. So x squared plus 4, we'll set that equal to 0. And then the x squared minus 3 we'll set equal to 0, and we'll solve each one of these. So for the first equation, we subtract 4 from both sides. We get x squared is negative 4. For the second equation, we add 3 to both sides. We get x squared equals 3. And then taking the square root of both sides, remember, when you take the square root of both sides of an equation, you have to consider the positive and the negative. So x for the first equation is plus or minus the square root of negative 4. And for the second equation, x is plus or minus the square root of 3. Now, the square root of negative 4, if you recall our talk in our notes on complex numbers, is equal to the square root of negative 1, which is I, times the square root of 4, which is 2. So the square root of negative 4 is 2i. So we have x is plus or minus 2i for our first equation. And over here, we have x is plus or minus the square root of 3 for our second equation. So if we list out all of our answers, we get x is 2i, x is negative 2i, x is square root of 3, and x is negative square root of 3. Notice each one of these answers, neither one of them is a rational number. So with solutions to polynomials, one of three things is going to happen. We'll have each solution, each root, each zero is either going to be a rational number, an irrational number, or an imaginary number. So we will see that in the next video as well. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.